Welcome to another quick math tutorial on past examination papers. Today we're going to be taking a look at a few probability questions, and I'm not going to be referring to my problem solving notes today, but what I'll do is I'll briefly make mention of them. And this is going to be a relatively quick tutorial, and I've made sure I picked out just a few of the most difficult probability questions. And don't worry if these problems might seem a little bit too difficult for you. This is a higher tier papers that I'm going to be looking at here. So alright, let's begin into our first question. So we have Cormac has some sweets in a bag. The sweets are lime flavored or strawberry flavored or orange flavored. In the bag, the number of lime flavored sweets, 2, the number of strawberry flavored sweets, 2, the number of orange flavored sweets equals 9 to 4 to x. Cormac is going to take at random a sweet from the bag. The probability that he takes a lime flavored sweet is 3/7. Work out the value of x. Alright, so this question obviously involves probability, and we'll need to know some ratio knowledge as well. So we want to work out the probability that he takes a lime flavored sweet. So we know that the probability that he takes a lime flavored sweet is 3/7. However, we would like to work out the value of x. So we want to work out this value here. Okay, so we need to set up an equation that has x as its unknown and its variable. So first of all, notice that we're given the probability for the lime flavored sweets, for picking a lime flavored sweet there. And from here we can also deduce the probability from this ratio here. So if we place this ratio, this whole ratio, in the form of a part over whole, then we could say the part which is 9 parts, which is the number of lime flavored sweets, over the total number of sweets, which is 9 plus 4 plus x, that's the whole, and that gives us 13 plus x. So now we have two probabilities for picking a lime flavored sweet, one in the form of 9/13 plus x, and one in the form of 3/7. So since 9/13 plus x equals the probability of picking a lime flavored sweet, and 3/7 equals the probability of picking a lime flavored sweet, well then 9/13 plus x must equal 3/7. Now we can simply rearrange our equation to get x by itself, and then we can find out x. So if we do a bit of cross multiplication, we have 9 times 7, which is 63. That equals 3 times 13, which is 39, plus 3 times x, which is x. Now we simply rearrange. So we subtract 39 from both sides. That gives us, let's see, 33 minus 9 is 24. 24 equals, 3x. X equals 8, or 8 equals x. So for our next question, we have a first aid test has 2 parts, a theory and a practical test. The probability of passing the theory test is 0.75. The probability of passing only one of the 2 parts is 0.36. So we're looking at some mutually exclusive events, since they cannot happen at the same time. The 2 events are independent. Work out the probability of passing the practical test. Alright, so now we're going to take a look at our second question. We have a first aid test has 2 parts, a theory test and a practical test. The probability of passing the theory test is 0.75. the probability of passing only one of the two parts is 0.36. The two events are independent. Work out the probability of passing the practical test. Alright, so let's draw a probability tree to get us started. So we can either have our theory test here, theory, and we have our practical. And we're told that the probability of passing the practical test is probability of passing the theory test is 0.75, which means the probability of failing it is 0.25. Now notice that we're not given the probabilities of passing the practical test. Okay, so since we're not given the probabilities, we have an unknown. And so what do we do if we have an unknown? We mark it with either X or Y or some other letter. Okay. Now we're told that the probability of passing only one of the two parts. Alright, so either passing the theory and failing the practical, or failing the theory and passing the practical. Okay, so we could pass theory, and so we can do both. We can both pass the theory and we could fail the practical. Or we could fail the theory, and we could pass the practical. So notice my two key terms here that I've decided to use is the and the or. And we know that in probability theory, and signifies multiplication and or signifies addition. So what I'm really saying here is that the probability of passing the theory, which is 0.75, times the probability of failing the practical, which is, we're not given the probability yet, we're just giving it as y, plus the probability of failing the theory, which is 0.25, times the probability of passing the practical, which is x, equals 0.36. Alright, so we could omit the multiplication sign just to make the equation look a bit neater. So we can say 0.75 plus 0.25x equals 0.36. Alright, so this is the equation that is really given to us in the question. So at this point you might get a little bit stuck and you might think, alright, so I have an equation here in two unknowns, and we actually don't have any tools to solve an equation in two unknowns. And so for that, you would have to make sure you would know that there's no other way to do this problem. And so since this is the only way to do it, there must be something that we're missing in order to make this work. And so then you would have to really make sure that you have all of your probability theory concepts at hand. Okay, and so if we remember that the probability, let's say it like this, the probability of, let's say, passing passing equals 1 minus the probability of not passing. Not passing. Alright, so the probability of passing, which is x, okay, equals 1 minus the probability of not passing, which is y. So really what we're saying is that x equals 1 minus y, and likewise y equals 1 minus x. Okay, so if y equals 1 minus x, we could now substitute this into here and make our equation into one unknown. So we have 0.75 times 1 minus x plus 0.25x equals 0.36. Multiplying out of brackets gives us 0.75 minus 0.75x. Sorry, 75x, yes, 75x plus 0.25x equals 0.36, which gives us 0.75 minus 0.5x equals 0.36. And so now we could substitute, we could subtract 0.75 from both sides. That gives us minus 0.5x equals minus 0.39, and then x equals minus 0.39 divided by 0.5, and that gives us 0.78. Okay, so our answer, or at least the probability of passing the practical test, is x, and we just calculated x. That's 0.78. Alright, so let's move on to our next question. And our next question is, Ray has 9 cards numbered from 1 to 9. Here's our cards here. Ray takes at random 3 of these cards. He works out the sum of the numbers on the 3 cards and records the result. Work out the probability that the result is an even number. Alright, so we're told here that he takes 3 cards, and we want to find the probability that the result of the 3 cards taken is an even number. So notice now, there are so many different combinations of cards we can choose. We could choose 1, 2, 3, or we could choose 3, 2, 4, or we could choose 4, 2, 5, or 5, 4, 3, or 5, 6, 7, or 7, 6. The possibilities are nearly endless. Not exactly endless, but there is a lot of different possibilities, different combinations of these cards that you would have to go through in order to find even numbers. So just to say, let's say we just took 1, 2, and 3. Okay, 1 plus 2 plus 3 equals 6. Or let's say we took 3, 2, 5. 3 plus 2 plus 5. That gives us 10. Okay, or likewise, let's say we took 2 plus 4 plus 6. 2 plus 4 plus 6. That gives us 12. And then we took maybe, say we took 8 plus 2 plus 4. 8 plus 2 plus 4. That gives us 14. And so we could keep on like this, but it will get very cumbersome. So what we could notice instead is that, notice that I have an odd number here for 1 and 3. They're both odd. And I have an even number. I'm adding an even number. and then I'm adding another odd. And on both of these occasions, they both come out to even numbers. Likewise here, I have an even number that I'm adding, plus another even number, 4 and 2, plus another even number, 6 and 4. 6 and 4. And that gives me an even result. Okay, and so the reason why that is, the reason why no matter what combination of numbers I choose, if they come as odd, even, and odd, it's always going to come to even, right? And the reason why that is, if you notice that odd numbers are of the form 2n plus 1, okay, and even numbers are of the form 2n. So if I add an odd number, so let's add an odd number, 2n plus 1, plus an even number, plus 2n, plus another odd number, that's 2n plus 1. What do I get? 2n plus 2n plus 2n is 6n, 6n plus 2. And notice that 6n plus 2 would also be another even number, right? Because we have an even number here, which is the 6n, and we're adding another even number, which is 2. Likewise, in this case, we have even number plus even number plus even number, which is 2n plus 2n plus 2n, and that gives us 6n. So it doesn't matter what combination of odd, even, and odd cards I use, I'm always going to get an even number. And it doesn't matter what combination of even numbers and even numbers I use here, I'm always going to get an even number. Okay, so rather than looking at the different types of numbers to pick that will take way too long, we can categorize each number in the form of odd and even. Okay, so saying that, Ray has 3 picks. He takes out 3 cards at random, so we'd have to put our first pick, second pick, and third pick. So for our first pick, let's say we picked an even number, and for our second pick we picked another even number, and then for our third pick we pick another even number. Okay, now don't get confused with the and at the moment. I'm just writing and. This and is really because after we find the probabilities, this and is for when we find the probabilities of picking even numbers. It doesn't mean that we're multiplying these even numbers together. I'm going to be multiplying the probability of picking the even numbers, but for now we're just adding these even numbers together. So what do we get here? We get another even number. Okay, so we can that's one probability that we can work with. So how about an even and an odd? What does that give us? Well, let's see. We don't have to use this formula here. We could say, 2n plus 2n plus 2n plus 1, but we can make it a bit simpler. We can just say, okay, even number, since the sums hold for any combination of even, and odd, we can just pick the numbers, right? So we could pick a 2, a 4, and a 1. Okay, that's even, odd, and that comes to 7. So we know that because that comes to 7, any other combination of even, odd that we pick is always going to come to an odd number as well. So that comes to an odd number, so we can't use that probability. We're not looking at that probability. Remember, work out the probability that the result is an even number. So how about even and odd and even? Right, really just the same thing as this one. It's just that I've kept the evens the same, and I've just swapped the odd and even around here. So that's also going to be odd, since it's really just the same combination as this one, right? But it's been ordered differently, so we can't use that one. Now how about an even and an odd and an odd? Now we don't yet have this combination of even and odd. We have one even and two odds. So let's check that out. Let's say we had a 2 plus, let's say a 4 plus, no, we want two odds, don't we? So let's say we had a 2 plus 1 plus 3. What does that give us? That gives us 6. So that's always going to sum to an even number. So we can use that probability there. Alright, so let's explore. Notice that I've exhausted all of my combinations of even even rows, or I've exhausted all my probabilities of these rows starting with even here. Okay, so I've kept this the same here. I have even, and then I just have even and odd, odd and even, odd and odd. Okay, so now I can begin with my odd numbers, starting with odd numbers as our first picks. So let's say I had an odd and an odd and an odd. What would that give me? Well, we can say 1 plus 3 plus 5. That gives me 9. Okay, so that's always going to sum to an odd number there. How about an odd and an odd and an even? How about that? Now, do we have an example of this here already? Well, we have 2 odds and 1 even. So let's see. So we have 2 odds and 1 even here. It's just ordered differently, same combination, and that comes to an even number, which means this must come to an even number. So we can use that. Okay, so how about an odd and a even and an odd? Again, we have 2 odds and 1 even, which is the same as this one, so this one would also sum to an even number. So for our last one, keeping our odd number as our first pick and just reordering the second and third pick, we have odd and, let's say, even and even. Do we have any examples of that? 2 evens and 1 odd? 2 evens, yes we do. We have 2 evens and 1 odd here, and that comes to an odd number, so we can't use that. Alright, so now we've got our different combinations of odd and even that sum to even. So it's this one here, this one, this one, and this one. So now we can just look at these separately. So I can have an even and even and even, or I could have an even and, let's put or there, even and odd and odd, or I can have an odd and even, odd and even, or I can have an odd, even, odd, odd and even and odd. So these are now my four possibilities here. Okay, so now let's take a look at the probability of actually finding an even number. So the probability of finding an even number would be, we have a sum of 9 cards, and we have 1, 2, 3, 4 even numbers. Okay, which means probability even, which means that the probability of finding an odd number would be 5 over 9. So for our first pick, the probability of getting an even number on our first pick would be 4 over 9 times the probability of picking another even number. Well, notice that since we picked our first even number, we'll actually have only 3 even numbers left. And since we've picked our first pick, we only have 8 cards left in the total. So now that comes to 3 over 8. Same thing happens again. We've picked 2 even numbers now out of a possible 4 even numbers. So we only have 2 even numbers left out of our pick. and only 6 numbers out of the total amount of cards. Okay, so we've had probability of even times probability of even times probability of even, or which is add. Notice that they can't all happen at the same time. Ray can't pick out an even number and an even number and an even number, and at the same time pick out an even number and an odd number and an odd number, which means these events are mutually exclusive. That's why we're adding them together. Okay, so we could pick out an even number, which is 4/9, times the probability of picking an odd number, which will be 5 out of, since there's 5 odd cards, now it'll be out of 8 since we've already taken our first pick, and then another odd number, so we would have 4 odd out of 6, or rather out of 7. Or we could pick an odd and an even. So an odd times another odd times an even. Or we could pick an odd times an even times an odd. Alright, so now we simply multiply the fractions we have inside the brackets together and then add the results. So I've noticed that I've made just a little error there. That should actually be 7, shouldn't it? Should be 7. And just notice that I have all of my denominators the same in all of these fractions. 9 times 8 times 7. So if we just do 9 times 8 times 7, we get 504 as our denominator. Since all of our denominators are the same, we can simply just add the numerators. So 4 times 3 is 12, times 2 is 24. 4 times 5 is 20, times 4 is 80. That's going to be 544 again. 544. So that gives us 80 plus 8 is 160, 240, 264. 264 over 504. Okay, so obviously you can simplify that further, and I would encourage you to do that on your exams. However, this is just me going through a few questions, so I won't bother doing it there. That's our answer, 264 over 504. There are only 3 red counters and 5 yellow counters in a bag. Jude takes at random 3 counters from the bag. Work out the probability that he takes exactly 1 red. Alright, so with these sort of questions, whenever you have a bunch of objects in a bag, and you take out, so you take out 3 or you take out 5, you can either think of it as, let's say Jude takes 3 at once, or 5 at once, or 10 at once, however many he wants to take out of the bag. Or you could think of it as though he takes his first pick, and his second pick, and his third pick out, right? And it's usually better to work with this way of doing it rather than taking it all out at once, because then you can break it up into your first, second, and third pick and work out the probabilities of taking each counter separately. So, saying that, Jude takes at random 3 counters from the bag. Work out the probability that he takes exactly 1 red. So we don't want to find the probability that he takes 3 reds or 2 reds and 1 yellow. We want to find the probability that he takes only 1 red on either of his picks, which means that his remaining picks must be yellow. So on his first pick he could take a red, and he could take a yellow, and he could take another yellow. Or for his first pick he could take a yellow and a red for his second pick, and a yellow for his last pick. Or he could take a yellow for his first pick, a yellow for his last pick, and a red for his a yellow for his second pick, sorry, and a red for his last pick. Alright, so saying that, the probability of actually taking a red out is 3/8. and the probability of taking a yellow is 5/8. So the probability of taking a red counter in this case is 3/8. So you could take a red counter, and for his second pick he could take a yellow counter. There's 5 yellow counters. Notice after taking his first pick he only has 7 counters left in the bag, so that yellow will be out of 7. That he could take another yellow. Since he's already taken his first yellow out, he will only have an option of 4 yellows to take out after, and that will be out of a total of 6 counters remaining in the bag. Or he could take out a yellow and a red and another yellow, or he could take out a yellow, 5/8, and another yellow, and finally a red. Okay, you get the point of why I've written it like this, right? After he takes out 2 counters from the bag, say first pick, second, third, first, second, third, first, second, third. So he takes his first pick, and the probability that it will be yellow is 5 yellow out of a possible 8 counters. Once he's taken his first pick, then he'll have 7 counters left, and once he's taken his first pick of yellow, he will only have 4 yellow counters left. Okay, and here he takes his third pick, and there's 3 red counters, and since he's already taken his first and second pick, there's only 6 counters to choose from. Alright, so notice here we just have the same fractions in all of our brackets. Okay, so essentially what we have is just 3 times 5 times 4 times 3 over 8 times 7 times 6. Okay, so that really gives us 3, really gives us 5 times 4 times 3 times 3 divided by 8 times 7 times 6. Now if we divide through by 3 on both sides, we get 5 times 4 times 3 over 8 times 7 times 2. Now if we divide further by, let's say we divide further by 4 on both sides, that will give us 5 times 3. That doesn't even look like a 3, does it? 5 times 3 over, let's say 2 times 7 is 14. So so basically we have 5 times 3 is 15 over 2 times 7 is 14 times 2 is 28. Okay. Alright, so let's move on to our next question. In a village, if it rains on one day, the probability that it will rain on the next day is 0.8. If it does not rain on one day, the probability that it will rain on the next day is 0.6. The weather forecaster says there is a 70% chance that it will rain in the village on Monday. So obviously that 70% as a decimal would be 0.7. Work out the estimate for the probability that it will rain in the village on Wednesday. You must show you're working. Alright, so we want to find the probability that it will rain in the village on Wednesday. We're given the probability that it will rain on Monday, and we're also given a rule that takes us from one day to the next. So looks like we'll need a probability tree in this question. I know we're used to having our probability trees going off to the right, but in this case I'm going to do it going from above downwards just so we have enough space. So let's say it rains on Monday. Say Monday, and it rains and it doesn't rain on that side. And then for Tuesday, the probability of Tuesday, the probability that it rains on Tuesday. And finally we have probability for Wednesday. Okay, and so we are told that the probability of it raining on Monday is 0.7. Let me just fill in the rest of these. Say not rain and rain, not rain and rain. We have not rain, rain, not rain, not rain. Alright, great. So we're told that the probability of it raining on Monday is 0.7, which means the probability of it not raining would be 0.3. Now we're given our rules that take us from Monday to Wednesday. Wednesday. And we're told if it rains in the village on one day, then the probability that it rains on the next day is 0.8. So if it does rain on Monday, probability that it will rain on Tuesday is 0.8, which means that the probability that it won't rain is 0.2, since the mutually exclusive events are always out of 1. So if it doesn't rain on Monday, the probability that it will rain on Tuesday, we're told it will be 0.6, which means the fact that it doesn't rain would be 0.4. And again, if it rains on Tuesday, the probability that it rains on Wednesday is 0.8. Probability that it doesn't rain is 0.2. Probability of it not raining on Tuesday means that the probability of it raining on Wednesday in this case will be 0.6, which gives us 0.4 in that case. Here we have rain on Tuesday, so the probability that it will rain on the next day again will be 0.8, which means if it doesn't rain, that will be 0.2. And then if it doesn't rain on Tuesday, then the probability that it will rain on Wednesday would be 0.6, and the probability that it won't rain would be 0.4. So we want to find the probability that it will rain on Wednesday, which means that we're interested in these events here. Okay. So in that case, it could either rain on Monday, rain on Wednesday, Tuesday, sorry, and also rain on Wednesday. So it could rain on Monday, which is 0.7, and rain on Tuesday, so that's times 0.8, and it could rain on Wednesday as well. Or we have addition for or it could rain on Monday, it could rain on Tuesday, sorry, it could rain on Monday, not rain on Tuesday, and then it could rain on Wednesday. So 0.7 times 0.2 times 0.6, or it could not rain on Monday, not rain on Tuesday, and then rain on Wednesday. So that's 0.3 times 0.4 times 0.6, or it could not rain on Monday, rain on Tuesday, and also rain on Wednesday. So there we have all of our probabilities. Now we can simply calculate these. 748. So that's our probability. Alright, so let's move on to our next question. there are only red sweets and yellow sweets in a bag. There are n red sweets in the bag. There are 8 yellow sweets in the bag. Sajid is going to take at random a sweet from the bag and eat it. He says that the probability that the sweet will be red is 7/10. Alright, show why the probability cannot be 7/10. Alright, so we're told that the probability that the sweet will be red is 7/10. Well, at least Sajid says it's 7/10. And we're also given the number of red sweets as n, so we don't actually know how many red sweets there are. But we could actually put this information in the form of the probability of taking a red sweet. So the probability of taking a red sweet will be n red sweets over the total of 8 plus n sweets. So that's the probability of taking a red sweet. Probability of taking a red sweet. And here we're also told that the probability of taking a red sweet is 7/10. So we can set these equal to each other. So n over m plus 8 equals 7/10. Simply do a bit of cross multiplication and we can find the value for n. So we have 10n equals 7n plus, is that 56? Subtract 7n from both sides, that gives us 3n equals 56. So n equals 56 over 3. What does that give us? 56 divided by 3. That equals 18.667. Alright, so notice here that we have a rational number, 18.667, and we can't have 18.667 red sweets in the bag unless someone's, taken a few bites of the sweet while it was in the bag. However, that's not stated in the question, so we can assume that the number of sweets can only come in positive whole integers, right? Numbers like 1, 2, 3. We can't have negative number of sweets in the bag, and we can't have like rational numbers like 0.7. So we've proved why the probability of taking out a red sweet cannot be 7/10, because if the probability is 7/10, that means there are 18.667 red sweets. Okay, and that can't be correct. Alright, so let's move on to our next part of the question. After Sajid has taken the first sweet from the bag and eaten it, he is going to take at random a second sweet from the bag, and given that the probability that both the sweets he takes will be red is 3/5, work out the number of red sweets in the bag. Okay, so let's say we have our first pick and second pick again, and so the probability of taking a red sweet on his first pick would be n over 8 plus n, and the probability of taking a red sweet on the second pick would be n minus 1, right? Because since we've taken a red sweet from the bag on our first pick, now we have n minus 1 red sweets left, right? And so that would also affect the total amount of sweets in the bag. So we'll have n minus 1 plus 8, which is really m plus 7. Okay, and we're told that equals probability that both the sweets he takes will be red is 3/5. So what we have is n over 8 plus n times n minus 1 over m plus 7 equals 3/5. Alright, so we can multiply these fractions together, which gives us n minus 1 over 8 plus n times m, well, let's keep it consistent, 8 plus n times 7 plus n equals 3/5. We can expand out the brackets. We'll do it up here. expand the brackets. So that gives us n squared minus n over 8 times 7 is 56 plus 8n plus 8n, or 8n plus 7n, which is 15n, plus n squared equals 3 over 5. Do a bit of cross multiplication. So that'd be 5n squared minus 5n equals 56 times 3 is 168 plus 45n plus 3n squared. Do a bit of rearranging, and already this looks like a quadratic equation. So that's going to be 2n squared minus 50n minus 168 equals 0. So we have a quadratic equation, and obviously the coefficients of this quadratic equation are quite large, so it looks like we could use the quadratic formula. So if you remember, the quadratic formula is going to be x equals minus b plus or minus the square root of b squared minus 4ac over 2a. So first of all, what I'll do is I'll just work out the discriminant inside the square root sign there, the b squared minus 4ac, just to make sure that we come up with we don't want to come up with a negative number because we can't square root a negative number, and b, I want to make sure that this number here, when it's square rooted, it comes to a whole number, because we don't want to have a rational amount of sweets again. We want to have the sweets in whole number integers. So b squared minus 4ac in brackets, that would be b squared would be minus 50 squared, or we can just say 50 squared, minus 4 times a, which is 2 times minus 16a. I'll just put that in the calculator. So great, we have a whole number here, which means that, oh, let me keep this consistent as well, because we say x equals that, but we're actually dealing in terms of n here, aren't we? So we can say that n equals minus b, which is 50, plus or minus 62 over 2 times a, which is 4. So either equals 50 plus 62 over 4, or it can equal 50 minus 62. 50 plus 62 over 4, or 50 minus 62 over 4. So obviously we can't have this one, because 50 minus 62 would give us a negative number. We can't have a negative amount of sweets. So we're left with 50 plus 62 over 4, which is 112 over 4, which is 50, 112, 56 over 4. It's going to be 28. So n equals 28. And what is n? N is the number of red sweets. So the number of red sweets, and is that our question? Is that our answer? Work out a number of red sweets. Great. So that's our answer for this question. N equals 28. Okay. All right. So let's move on to our next question. There are only R red counters and G green counters in a bag. A counter is taken at random from the bag. The probability that the counter is green is 3 over 7. The counter is put back in the bag. 2 more red counters and 3 more green counters are put in the bag. A counter is taken at random from the bag. The probability that the counter is green is 6 over 13. Find the number of red counters and the number of green counters that were originally in the bag, or in the bag originally. Alright, so the probability of taking a green is 3 over 7, right? So, which means that the probability of taking a red in this case is 4 over 7, right? So if we put that in the form of a ratio, let's say we have red, green in the form of a ratio. So that means we have 4 red to 3 green. Okay. So notice first of all with ratios, just a quick reminder on ratios. let's say I had let's say I had a bar of chocolate here, and there's nine parts to it, right? Now, let's say I had, say, three chocolates with red wrappers, and I had the rest were green chocolates or chocolates with green wrappers. Then I would say that the number of red to green chocolates is 3 to 9, right? And then we could simplify that ratio further to 1 to 3. But that doesn't actually mean, someone might come along and be like, okay, so the ratio of red to green chocolates is 1 to 3, which means there must be 4 in total. But there's not 4 in total, there's 9. So that's one thing you have to bear in mind about ratios, is that they measure the relationship between two things. Okay, so there are 3 green chocolates to every 1 red chocolate, right? So really what we have is 1x to 3x. Okay, and so in this case, if x equals 3, then we'd have 3 to 9. Okay, so even in this case, this is not saying that we have 4 red counters and 3 red counters, 3 green counters. What we're really saying is 4x and 3x. Okay, so just bearing that in mind. So the counter is put back in the bag. 2 more red counters and 3 more green counters are added to the bag. So okay, so 2 more red counters, that gives us 4x plus 2 and 3x plus 3. Okay, the probability that the counter is green is 6 over 13, which means, again, we can put this in terms of ratio. This is a part over a whole, over the whole, which means we have green, which is 6 parts, and then 13 minus 6 to get the other part, the other number of red parts, which is 7. So now we can just pay attention to this lovely little ratio here. We can place the 4x plus 2 on top of the 3x plus 3, or over the 3x plus 3, and do likewise with this part of the ratio. So 7 over 6. Do a bit of cross multiplication. So 6 times 4, that gives us what, 24? 24x plus 12 equals 21x plus 21. Do a bit of rearranging, that gives us 3x. 3x equals 9, which means x equals 3. So we want to find the number of red counters and the number of green counters that were originally in the bag. So this is our number of counters that are originally in. We found the value of x, so if we just plug that in, green, that gives us 4 times 3 and 3 times 3, which is 12 and 9. So we have 12 and 9. Okay, so let's move. Okay, so we finished our probability questions for today. Again, I wish you all the luck in your exams, and I'll see you again soon.